Hello guys, I am Ali Jawad and welcome to my YouTube channel. In this video, we will discuss lesson number 3 of chapter number 22, Electromagnetism from Cambridge Physics Syllabus 5054. So those viewers who haven't watched the lesson number 1 and 2, they are recommended to do so. I am providing link here in the video. In this lesson, we will continue with current carrying coil in magnetic field. So, in our lesson number 1, we have learned that whenever a wire is placed in magnetic field carrying current, so how it will experience forces. Similar to that, today we will learn that when we place a coil carrying current in magnetic field, so what can happen to that? For the sake of simplicity, we have considered one loop. So when the electrons are allowed to travel along the loop, means we are passing the current through the wire. So the electron moves from one end of the coil to the other. Here we can apply Fleming's left-hand rule to identify the direction of current, magnetic field and forces. So according to the left-hand rule, the index finger will give the direction of magnetic field, the middle finger gives the direction of current, and thumb represents the direction of force. So the left wire is experiencing the downward force shown with the green arrow. However, what will happen to the opposite end of the wire? Since the direction of current may get reversed, so it will experience another force which is directed in the upward direction. So if we may apply the Fleming's left-hand rule again, this is giving the direction of magnetic field. The middle finger will give the direction of current, while thumb will give the direction of force. So one force is acting downward and other is acting upward. So it produces a couple. The couple forces generates the moment or turning effect. So the coil will start to turn within the magnetic field along a fixed line of axis, like this. Whenever a coil carrying current is placed in a magnetic field, it will experience a turning effect, like this. We can make a model by using a copper wire, some magnets, and hot glue gun and paper clips. So observe that how the coil and the magnet has been arranged using the paper clips. Now we can connect the terminals of the battery with both of the paper clips to pass current in the copper coil. So when we will provide current and magnetic field is there, so turning effect should be produced. As you can observe, the turning effect is generated in the coil. Now, what can affect the turning effect? There are multiple variables which can. One is the number of loops. As we increase the number of loops, the turning effect increases because for every loop, the force will be there and the forces will get added together to produce an increased turning effect. Similarly, magnetic field is also another variable. If stronger the magnetic field, the more turning effect will there be, and lesser the magnetic field, the lesser turning effect will be observed. The third variable which can increase the turning effect is current. As we increases the current, the turning effect increases. As we decreases the current, the turning effect decreases. This effect can be used in DC motors and alternating current generators, and in the videos later on we will see that how we can use the coil carrying current to make DC motors and AC generator respectively. I hope that you have enjoyed the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching.